Let's talk about international very briefly. Because when you scale up, you're going to hit different countries, and you're going to have to deal with that stuff. So there is only one time zone for computers. It is UTC. There is no other time zone for computers. If your computer is not UTC, you are wrong. Unequivocally, you're wrong. So PST is for people, or is it PDT? Is it PDT? Is it PST? I know Congress changed it, and it used to be this one time, and then it was this other time, and then I was on a project where I didn't sleep for a month updating all of our servers because that changed. Never, never, never want to be dependent upon what that time zone is. If you have things that are in daylight savings time, you have to make sure that I run a prod job at 2:30 in the morning, because it's either going to run twice or never. One out of the year. It's going to happen. Like, look it up. This is what happens. So always on UTC. Now, you have graphs and stuff that you're going to look at. I don't want to remember -8 or -7, because again, I can never remember what the difference is. So, you can make graphs display in the correct thing, but all of your data and all the things your servers interact with have to be as UTC. The other thing is that time is never consistent. So you have NTP on all your servers, and NTP is the network time protocol that makes time consistent on all your servers. Except your servers have a 3-cent battery in them, maybe it's 1 cent. If they paid 6 cents per battery, that would cost the server manufacturers more money, but it also keep accurate time. If you turn off NTP on one of your servers and have it do some work, it'll drift by a good solid hour over the course of a week. And just be completely off. It will. Try it. Well, actually, don't try it. Staging. This is what staging's for. So if you're making design assumptions that, okay, well, cool, we're going to have somebody log in that's going to create a session token, and we're going to cryptographically sign it and make it valid for 5 seconds. And it'll be used everywhere else throughout the system. It'll be only valid for those 5 seconds. That sounds like great security until NTP screws up and suddenly it's generating things that are off by 5 seconds. The server being off by 5 seconds is not unrealistic. This will definitely happen. So you need to design things with flex for this, because servers are actually bad at keeping time. Territory coding. Just use UTF-8. Don't use anything else. Does anybody know what that UTF-8 character is? Anybody? Anybody? It's an emoji. Look it up later. A lot of UTF-8 implementations are comically bad. MySQL has a very terrible UTF-8 implementation. The default one doesn't support 4-byte characters. So you actually won't have that work for it. A lot of different parsers in different languages that parse UTF-8 won't actually deal with a 4-byte character. Everybody loves emojis. They're super cute in text messages. But if you notice when they started to become popular, a lot of apps that you use didn't actually work with them, maybe because the server wasn't actually prepared for it, or you weren't prepared for it. So you can't manage what you can't measure. So capacity planning. So we're at 95%, it's fine. Everything will be fine. Don't worry, we're not overflowing yet. So how to do capacity planning when you are at a small scale? Start with basic trends. It's very simple. We were at 50% this last week. We're at 51% this week. We grow 1% week over week. We will be out of business in a year. We should probably work on this. Most people look at this as we were at 80% last week and are at 81% now. Oh no, we grow 1% week over week. Oh my God, I need to update my resume. This is the simple way of doing it though. Tie growth rates to your simple week over week. This actually gets you a really long way in the start. You can do the cocktail napkin math. Maybe do some things like, hey, we had this many QPS last month, and we have this many this month, and we have this many database queries last month, and this many this month. That's more or less our growth curve, and it gives you a decent spike number. You probably also want to be prepared to have at least 50% overhead of capacity because you're not doing real capacity planning though. Then you're going to get to better capacity planning, benchmarking all the things. Benchmarking is actually a really hard problem. It's really easy to run, Apache Bench against a web server and see how many requests it'll spit out for a file that is cached in memory. That works great. When it is going through your application that does 3 database calls and then a call up to a service and then a bunch of disk accesses and then is also handling uploads at the same time and DNS is not working, that is a much different beast. So what you need to do is benchmark your individual service, have a good idea of that, and then benchmark your entire stack. Because if your database is your bottleneck, then it doesn't matter how many QPS your Java server can do because the database is going to fall over at 50 QPS. How many IOPS your disk drive can do if the database doesn't have any RAM for it, and all the things like that. So a lot of this comes down to queuing theory. So everything on your system is actually a queue. So when you put bytes into the network, they go into a queue. They actually go into a queue on the network card. Well, they go into a queue in TCP, and then they go into a queue on the network card, and then they go out into the internet, and then they go into a queue on a router, and then a queue on the other side, and the other side, and the other side. Everything works great until that backs up. There's actually some really cool literature that a guy put together on a concept called buffer bloat, which is why your cable modem runs terribly. And that's because it has lots and lots of queues inside of it. So when you're benchmarking, what you want to have an understanding of is what these queues are and how they behave when they actually fill up. Do they fill up in a bad way and start dropping things? Do they fill up and just take down everything else? CPU is the same kind of way, disk I/O, web requests, things like that. You can figure out how your queues back up, and you'll understand where your bottlenecks are, and be able to assess where the states of your queues are, and then if they ever get to the point where they are over one backlog thing, you know that you're already going to be in trouble. And then you do capacitive blending the real way, which involves math. And math is really hard. Like I remember when I was in college that those things meant things. Why? I think it's division, I'm not sure. So you will actually have to learn how to use R. R is a super great mathematics programming language framework, cool thing. And you'll have to figure out how to instrument your code and be able to know how each little chunk of your code is going, which parts get slow, where your database slows down, all of those things. Then you start to use all of the laws of computer scalability to actually build this up and build a correct model of all of your stuff. But this is actually really, really hard. But once you get up to that big scale, you're going to find somebody who still remembers statistics, and they will actually be able to do this, and it'll be awesome. So let's talk about some monitoring at scale. So log everything. By that I mean, oh dear God, do not log everything. Metrics are useful, log messages are not. You can turn log messages into metrics, but log messages themselves are not useful. They are made by developers for developers. I have been the developer, I've been the prod-eng guy. It's definitely made by developers. They do not make any sense when it's not the code you wrote. And when you have 100 hosts, aggregating all these logs is super, super non-trivial. I love Splunk as a product because they solve this problem of turning your log messages into metrics as well as giving you a way to look at all of your stuff. That stuff is expensive, man. This is hecka expensive, and it takes up a ton of disk space. And then you get backlogs, you can actually capacity plan your syslog server, and everything just falls apart. Everybody's complaining about it. So logs should exist on your server so that when something is broken, your developer can log in or you can log in, you can actually look in and inspect that. You can take advantage of your asset management database and log into all the servers within that service and tail all the logs at the same time. But you don't actually want to be sending all that down to a central place because it's not actually useful. If you can turn it into metrics, then you can turn it into a pretty graph, and then your smart human brain can parse that graph and figure out what's wrong and what's not wrong. That actually in terms of graphing. Graph everything. Oh my God. So graphing metrics is way cheaper than log messages because it's a little blip on the thing, RD is super efficient, or graphite, or whatever the heck you want to use. You want to graph everything as often as you realistically can. And you really need to invest effort into building up a scalable graphing solution. So you can partition things and spread things out. 5-minute intervals are not great because sometimes there's spikes in latency that come and go, and you're going to miss those things. So you need something that can let you collect metrics as often as possible. And 99 percentile is often much more important than actually getting an average. So 99 percentile, it seems like, well, you know, it's only a really tiny bit of traffic. Well, yeah, you do 1,000 queries per second, so that's 10 queries per second that are in the 99 percentile. Maybe statistics is hard, like I said. But that would be the case that, you know, your 99 percentile is a 3-second page load, then 1 out of your 100 users is super, super sad because your site basically is borderline unusable to them. Like, you can get away with a 3-second page load once because they hit the Comcast router and they yell at it, and then they hit refresh and it works quickly, and they're like, stupid Comcast breaking everything for me. But you don't want that to be a consistent experience, and you want to find out about this before 100% of users are sad. If you do it based on an average, 50% of your users are having a real bad time, potentially, before you've actually even noticed that something is wrong. Now let's talk about some advanced monitoring. So this takes a large effort between yourself, your developers, and all of your different systems. What you can do is generate an isotope, which would be a request with some sort of magic header or something that is tagged to it. And you inject this into the front of your system and make sure it spits out the back. So it would be something of, let's say you're taking, let's say you're serving ads. Ads is a good example of this. So I want to be serving ads and I want to make sure that an ad actually is being served and we are paying people for it. So I make a fake one of those and I make something automatically click that and send a magic thing to it. Then I make sure on the other side of the system it spits back out and says, yes, we actually did that and got all of that. And if you have isotopes like that, then it doesn't really matter if the middle of your system is, quote, broken or slow, as long as your isotope makes it through the whole way, because then your user experience is actually really, really good. You just want to make sure that everything looks good for all of your users, and that your system is actually functioning. If chunks of it are broken, yeah, it doesn't really matter, who cares? So let's actually talk about paging because of that. So the service is the only thing that matters. So you need to figure out how your service is working. So I don't actually care if my web server and the process behind it is taking up 100% of CPU, if it's serving 10,000 requests a second in 1 millisecond. That's super awesome. Like, use that CPU like a boss, you're doing great. But I care if stuff is getting slow. So really all you're worrying about is, for the service overall, is it in a bad state or is it in a good state? And when you pull this thing in an aggregate, then you don't have to page for hosts. You can mail for hosts. You can have graphs about hosts. You can get web pages about hosts where you look them up every day. But hosts don't actually matter. You have at least 3 of them for your service. One of them blows up at 2 in the morning. Your site is still performing in the exact same way it was before. You have not lost any data. Everything is fine. That sounds like tomorrow morning's problem, not right now's problem. And that's a big thing, and it's hard to get used to that because you start out being like, I'm going to monitor IO stat and top and VM stat and all this other stuff on my things, but it doesn't really matter if your actual service is working. And then you get to sleep. Yeah, that's my cat. So yeah, I talk really fast, so sorry about that. Hopefully you liked it. Any questions? That is also my cat. I like cats. They're awesome. Anybody? What's up?
So I'm not an ops guy, but I don't know what the term is. Security is red team, basically testing for, security vulnerabilities in ops. I know the Bill Burns Netflix talked about things like the chaos monkey, proactively running processes to try and actively take down folks. What the heck is that called? How do you go about that?
So the question was akin to red teaming and security, where you actually try to attack something, like the concept of Chaos Monkey that takes things down. You're asking like what the term is, or what?
What the term, what the tools and approaches is that?
So if you're at a moderately mature infrastructure, you don't need a Chaos Monkey because you've got Puppet and that'll take things down for you. Sorry, yeah, Puppet has done bad things to me, and I think I did it to it, so it's not its fault. I actually don't know what term I would use for that. I would probably use Chaos Monkey because I would think was the first time I had heard about that. I actually think that's a really interesting concept of intentionally making things break at an often basis. So a good use case for that, take database failover. Databases generally are something that won't automatically fail over because it's a hard problem. Even if you have something that does that automatic failover, it still doesn't happen that often. A great example of that is you have staging, you're constantly sending data against your staging environment, just constantly sending requests to it, and then have a script that fails over your database once an hour at some random period of time and see who gets paged and see who notices. And that's the same kind of thing. I would not necessarily go as hardcore as Netflix would immediately of just like, well, I actually don't think Chaos Monkey ever ran in production. Maybe it did. But I actually think it's a really good concept because then you have a good solid understanding of what your failure cases are. And then once you know what they are, then you actually are prepared for it. And then once something real fails, like it's just another day at the office and not a big deal. Anybody else? Yes?
Yeah, any advice if you're doing web apps and you're in the middle and front end stuff, what things should you wear out? I mean, other things such as good design and not hitting the database too much, but are there any special things you should be thinking about in a SaaS environment versus enterprise?
So, special things to think about for web app development, you said?
Yeah, SaaS vis-a-vis.
For software as a service versus something else. The big one I touched on, separating reads and writes and being prepared for scalability is a huge thing. Make sure you don't cache DNS forever. DNS names change. That's like a trick people do to shift traffic around. So be prepared for that to change. What else off the top of my head? That's tough. I don't have anything better than to just separate reads and writes. Sorry. Yes?
So first comment I had was screws are redundant and stainless. So how do you manage them? And second is why would you worry about squirrels if you can put everything on AWS?
So the first thing you said was servers being redundant and stateless? Sorry.
Squirrels.
Oh, squirrels! Oh, yeah. So why would you worry if you're putting everything on AWS? Because AWS is vulnerable to squirrels. That's the first reason. Everything is vulnerable to squirrels. So if you can truly build everything to be stateless and redundant, which is potentially a really hard problem if you're dealing with any sort of data, but if you can do that, then you don't have to worry about any of that stuff, and it's a really, really easy, it's basically a solved problem at that point. The challenge is that it's really hard to get to that place. I have very rarely seen a system that was actually built to handle any level of catastrophic failure without human interaction that has really worked, aside from things that are like serving a read-only content-based website. If you're just serving up pages and nobody can update those pages, then that's super easy to scale up. But as soon as you actually have to inject new data into that, it becomes a harder problem. I don't know if I answered your question. Fair enough. Yes? So I went on 3 on drone tasks. That's awesome. But in terms of graphing, so I have used both graphite and RRD. I actually, graphite's kind of cool and I kind of like it, but I have a little bit of a love in my heart for RRD. It is some terrible, full of sadness code. Please don't open up that .c file. But it is a really, really awesome format. If you actually have somebody who's a designer put a graphic front end on it, it's a really powerful tool, especially since it'll cycle through and get rid of that old data. Because I don't really care about 10 millisecond or 10-second metrics from a data a year ago. I care about a rolling average. So. Asking about D3. So yeah, D3 came out of Square. So yes, we do use some of that stuff. D3 is cool. The cubism stuff, which is kind of a good way to put front ends on top of that stuff. So Mike Bostock had worked at Square before, and he wrote all that stuff. He is a visualizations god. He explained more to me about how, as a human, I could visualize things better than a computer, better than anyone else had. And so that stuff is super cool from the standpoint of being able to visualize your data. So you need to shove it into something. And what that something is doesn't really matter as long as you can make it scale. And then it's finding somebody who really cares about trying to visualize data and getting them to visualize it. Because having a wall of 8 billion graphs is also not necessarily useful. You don't have a way that you can look at them all at the same time and make that assessment of it. If you're doing command tab to switch between different web pages and see if the graphs line up, you probably don't have the best graphics set up. Hey, I've been there. I have done that. Looks great. Yeah. Anybody else? Yeah. What's up?
Two questions. First of all, you mentioned about host names. So you say it's something is it about host name? And just first question, why do you need host name when you have just CNS that will resolve this issue? And second question is why do you use this? Why don't you use, for example, Amazon or stuff? Because this technology is exactly for ours as well.
So the first question was about why do you even care about host names? You can just use DNS to point at it. The other half was why do you care about it in general, but you can use technologies like things that Amazon have done that kind of already solve this problem. So for the first part of it of host names, is because people are going to log into actual things. And when they're on that computer, the actual name that it spits out in front of them is going to be meaningful to them. And so if you take that away as being a signal to somebody, they can't be confused about what the actual role of the box is. And then yes, you would want to use DNS and a load balancer or something that aggregates the services in terms of the actual logical name for it. But for an individual given host, since it's just part of the service, what its name is actually irrelevant. It's either the host that is broken or the host that is not broken, or the host that we are doing maintenance on or the one we're not doing maintenance on. And it's the case of people who built technology to kind of wrap things up into overall services. And actually, I know some of the AWS stuff I play, but I log in and I get this nasty string of characters as my host name that doesn't make any sense to me. And I actually think that's a great feature because then I can't fall in love with that being my special snowflake. It's just another one of my 10,000 servers. Anybody else? Yes.
We give you couple of examples of R code that you use today? The top two.
Which code?
R.
R. No, because I'm not actually a capacity planning guy. Sorry. Yeah. I don't. I can talk about it, and I got to the math is hard part, and then that's where I have deferred to other people who are super smart to use R and figure that out for me. Yes.
So you mentioned about logging and said maybe centralized logging is not that useful, and instead examine host logs. So do you have any more comments about that? It's kind of struggle about like whether to centralize log and maybe store it in a database or not, so that's easy to do querying stuff.
Yep. So the question was about just saying a little bit more about centralizing logging versus leaving it on hosts. Yeah, there is an advantage of centralizing this because it's a single place where you can query against stuff. The point I'm making is that generally a lot of the actual log messages themselves aren't necessarily useful, and you could have them be turned into some concept of a metric. Like how many 200 OK requests we got for this given URL that can be rolled up to something that can be kind of a histogram and just be another data point in a graph. And then if you actually need to inspect something, you can go and find the server or find the servers that was on. It definitely is advantageous to have them centrally, just that as you get up to having 1,000 or 10,000 servers for a job, it just becomes unrealistic to store all the data. I've talked to people who have worked at very large companies who have tried to solve that problem and have just ended up buying tons and tons of filers from NetApp or EMC or whatever, and this giant, massive Hadoop cluster, and they do this insanity because they were like, oh, we outgrew Splunk or something like that. And it just becomes this huge sink when, in other cases where I have left logs on my servers, never sent them down, and just only sent back metrics, it's been enough signal to me when I've been doing operations that I've been able to figure out where something is being a problem and then go over to be able to actually investigate it. And then still get the data off the host. Yep.
So basically, you would collect the metrics on the server instead of sending the logs to a central place and then getting metrics out, throwing the logs away and keeping the metrics.
So yeah, that was, would I collect metrics on the server and send them back versus sending the login and then collecting the metrics on it? There's trade-offs with it. It's easier sometimes to collect the metrics on the server from a development standpoint. If you are using something that can handle the scale of sending log messages down, like some sort of message queuing system, if you can get them all down to a central place and then extract the metrics, that has a nice advantage because that is a single place you have to update to get more out of it. Also, if somebody really needs to look at it centrally at one point in time, they can just tap into that stream temporarily and pull that out of there. So I would say that sending them and extracting the metrics is probably better than doing it on the host, but just getting to the point where you're just doing metrics is super valuable in general. All right, I think I am out of time. Oh wait, yeah, sure.
So what techniques have you used to optimize performance for international users?
What techniques have I used to optimize performance for international users? It's really simple. You put servers right next to the users. And I am not being snarky with that. That's actually a very, very true thing. So one of the easiest tricks that people have been using these days is putting reverse proxies very close to the users. If you cut down TCP handshake times, then it makes pages load faster. It's very, very easy to test and prove this. And then long-lived connections, even back to the US. If, for instance, let's say you have users in Japan, if you put a reverse proxy right in Japan and have proxy everything back to the US, it'll load way, way faster for international users. That's the easiest trick. When you get more fancy, then you need to have either a sharded data store or be doing some sort of fast replication and be smart about when can I do a read locally or when is it replication lag and things like that. But the easiest solution is just slap a box of pairing points on there. Cool, all right. Well, thank you everyone for listening to me ramble for 45 minutes.